trigonometry. The idea with trigonometry is going to be very, very simple. It's basically on the name. Even if you don't know it right now. What is metric?
Measurements?
For measurements.
Yay!
Measurements. Excellent. And trigonal is
Three sides. Three sides.
so tree from tree. Number 3.
And the study, Ghana is from
Gono?
the study. It's from the study, I don't know.
No, sort of, but mostly angles.
Okay.
So we are going to measure angles, or we're going to have relationships with angles.
Okay.
We're going to have relations with angles. What is a relation in math?
Relation.
Something that basically is connected to something else by a pattern.
Okay.
So relations with angles. Particularly on a right triangle, we're always going to have our 90-degree angle, right?
Yes.
What is opposite to it?
The hypotenuse.
The hypotenuse. Okay. And what were these two called?
I don't know. But it was
Legs.
I'm
I'm gonna make them a little bit down because I need to write down something further. Okay, so leg. Okay, I'm going to take one of those ones in order to explain something.
Okay.
For this particular example, I'm going to choose this one. But this thing is going to apply to the other one as well, just in its own perspective, okay?
Okay.
I'm going to name this angle alpha.
What?
Alpha.
And why it's like a fish? Not
Yeah,
completed.
I'm very bad at drawing Greek letters, but that's all.
was it? Wait, then which one's the triangle?
The what?
No, that's a triangle. No, that looks like a foot.
Side?
Huh?
Side.
Sorry.
The one that looks like this?
Yes, that one.
Side.
And omega is the one that's.
Like something like this, I think.
Yes, that one. That's omega.
Yeah. Well, let's not lose track of it. The idea with trigonometry is that we're going to start with our most basic concept that is going to be our trigonometric ratios.
Okay. How do you do?
And they are ratios because they are going to be fractions, divisions of two things.
Oh.
What are they going to divide? Sides of the triangle. And they're going to be in perspective according to this. Okay, so in perspective to alpha, the angle that is next to it is called adjacent angle. Adjacent leg.
Okay.
Adjacent leg is the one next to it. Okay? When something is adjacent, it's because it is next to it.
Yes.
And what do you think I'm going to name this one?
Lejos.
It is on the other side.
Opposite.
Opposite.
Okay. Why is it? Okay.
Opposite leg.
Okay.
Okay? So we have adjacent leg, opposite leg, and hypotenuse.
Yay.
And right now what I'm going to do, I'm going to introduce the three most common trigonometric ratios that are going to use these things.
Okay.
The first one is called sin.
Same.
Sin. And it is abbreviated as sin.
Okay.
That's
Just take out the letter.
I didn't know the school were religious.
Okay, now if you go to your calculator, you can find it there.
Really?
Yes.
Where?
Here.
Where?
Sin.
I don't find it.
And the keys of the
I
middle.
find it.
Yep.
Ooh.
Okay. So the way that this is operated is the following. You're always going to have sin of an angle. In my particular triangle, alpha. Okay? I can also do it for the 90-degree angle or the other one. Right now we're working with alpha. So sin of alpha is going to be very simple. It's going to be whatever value I have on the opposite leg, so opposite leg, and I'm going to divide that by the value of the hypotenuse.
But, Profe,
Yeah.
what is sin? Like, what is.
What is a sin?
No.
What is like? What is it?
Uh-huh.
Very, very, very good question.
No, but in trigonometry.
I'm gonna answer a little bit more on that next week. For now, what I want you to have is that it is a ratio and it is related to weights. The sin answers to a curvature,
Okay.
but we're gonna explore that later. For now, having to account that sin is gonna be the opposite leg divided by the hypotenuse.
Okay.
It's a way to calculate the angle.
It's a way to calculate the angle, and it's also a way to calculate the sin of the angle. So if you go ahead and calculate this,
Okay.
you're missing the angle, you can apply an operation there to get it. But for now, I'm going to give you the angle, and I'm going to ask you for the sin. You just divide the things, and you will have it. Okay?
Okay.
The next one is called cosine. Why cosine? Because it is next to the sin.
And it's this?
Yep.
Yes, cos because it's
Oh,
next
It's
to
the
the
one that is
sea.
next to it, so cos.
That is so
They're
pretty.
friends.
Cos of alpha is going to be working. If I use the opposite leg for this one, who do you think I'm gonna-
Adjacent.
I'm gonna use the adjacent. So adjacent leg. And who do I divide by?
Hypotenuse.
Hypotenuse.
Why are they all like
Cosine.
relatively?
Alpha?
Yeah.
Because
Ah,
all of these ratios need an angle. Okay. The last one is a name that might ring a bell, but in a different context. Tangent.
Oh, yeah.
No, didn't ring a bell.
Tangent. Do you remember when you were studying the circle?
no.
The line that touches in one point is called a tangent.
Really?
Yeah.
I didn't know.
You didn't know that? Oh wow. Don't worry.
Oh, yeah. I know it.
Okay. There's hope in humanity.
Okay.
So,
Maybe I know. but
you
I don't
know
remember.
I'm like that. So tan is gonna be the abbreviation.
Yes.
And this one is gonna be alpha as well. And alpha. What do these ones have in common?
They
Yes.
all
Hypotenuse.
So who do you think doesn't go here?
Hypotenuse.
okay.
So opposite leg divided by
That is
adjacent leg?
Opposite leg divided by adjacent leg.
That is why tan is the equal to con and sin. See that?
Something like that. Opposite divided by
And you
adjacent.
can put
Right.
cos.
And like, and actually there is another formula for this one. Tangent is also equal to sin
And how do I put
of
alpha?
alpha divided by cos of
Okay,
alpha.
put alpha on the.
Either one works.
Can we put
Tangent is
alpha?
also the sin divided by the cosine.
Okay, can we put
I don't know, I
alpha?
prefer opposite leg on this.
Yeah, but you put alpha here, here.
No, but I'm this in the calculator.
On the calculator, you're not going to put alpha, you're going to put the value of your angle.
Okay.
Remember,
number.
alpha here represents any angle.
Okay.
Okay? These are the basic formulas.
Okay, you cannot erase anything.
Okay, just go ahead and make sure to copy that.
Alright.
Alright. And briefly, let's do an example.
Okay.
Let's imagine I'm going to work with this triangle. So you know, e.g., exempligrafía. Okay. I'm gonna work with the same position for my example. This one is going to be equal to 35 for this particular example. 35 degrees. Okay.
Okay.
And let's say this is going to measure 5, this is going to measure 4, and this is going to measure 3. Your usual should be. So let's say sin.
Wait, shouldn't it be the other way around because 4 is there?
Yes.
You have a very good point.
First should be the opposite.
Let's work it for this like now because what I want you to calculate is the ratio. Sin of 35.
So, wait. Sin of 35.
Correct.
It will be
4
3
divided
divided
by
by 5.
Opposite, so 3
divided by
divided by hypotenuse 5.
5. And it's
This
0.6.
yeah, 0.6. Infinite?
No.
Exactly.
Yeah.
Okay. Not a problem. So 0.6.
Wow.
Cosine. What do you think?
And
35.
units?
It's
I don't have a unit right now for this one, 2,
Okay, nothing.
because it is not an angle itself, it is the ratio.
Okay, it will
So
be
the unit is gonna be the measurement.
4 divided by 5.
Mhm. The thing is that if this had a unit, it would be here and here, so those units will cancel out, so this is just gonna be a ratio.
so it wouldn't have a unit.
This is my unit.
Okay.
It will be 4 divided by 5.
Cosine of 35,
4 divided by
adjacent 4, divided by hypotenuse 5,
And it's 0.8.
0 point. Tangent,
It's 0.6 divided by 0.8.
0.6 divided by 0.8.
It's 0.75.
Okay, or you can also get it by doing the more common one, the opposite, 3, divided by the adjacent 4, which is also 0.75. And that's how you calculate C, cosine,
The adjacent?
percentage.
No.
Okay, wait.
The opposite by the adjacent.
Opposite divided by adjacent. Okay?
Yes.
And this is just the tip of the iceberg for trigonometry. But for now, we're going to work with this, okay?
Wait.
It's very fun.
It's curious. There is a lot of curious applications to this. And there is a point in math where it's all over the place.
Ha.
But for now, every time that we're going to work with angles, we're going to refer to trigonometry. And we're going to work with this